So let's talk about the device you probably have in your pocket or on your desk right now, your mobile phone. It's this sleek slab of glass and metal that has become the central hub of our modern lives. It's your camera, your navigator, your music player, your connection to the entire internet. It's a powerful computer that just happens to fit in the palm of your hand. A concept that was pure science fiction not too long ago. Remember those? The ones with the curly cord that tethered you to a wall? A landline phone had a physical wire running from your house all the way to a local exchange. It was reliable but incredibly limited. Your mobile phone, on the other hand, is all about freedom. The mobile part is key. It cuts the cord, literally. The leap from wires to wireless changed everything. It's the difference between a horse and buggy and a sports car. It transformed the telephone into a personal companion that travels with us. The technology leap required to make this happen was immense. From copper lines and physical switches to a wireless web of towers and frequencies. It's why you can be on a bus watching HD video while someone next to you is on a call across the planet. This personal connection is what makes the device so integral to our daily routines. It's not just a tool for talking. It's a portal to our social lives, work, entertainment, and knowledge. And it all starts with that incredible ability to communicate without any strings attached. So how does your phone actually make a call without any wires? It all comes down to the science of radio waves. Think of it like a super advanced two-way radio. When you speak, a tiny microphone converts your voice into a digital signal, a pattern of ones and zeros, a digital fingerprint of your words. Your phone's antenna takes that digital signal and encodes it onto a radio wave. This modulation lets the wave carry your voice as it travels through space. Broadcast out in all directions, traveling at the speed of light. These radio waves are part of the electromagnetic spectrum, the same family as visible light, microwaves, and Wi-Fi. They're simply invisible streams of energy vibrating at a frequency. Each carrier band is a different lane in the sky. Each mobile carrier is assigned specific frequency bands by regulators. This prevents your call from interfering with your neighbor's call or a radio broadcast. Think of it as dedicated invisible highways in the sky. Those dedicated lanes help signals avoid collisions. Once sent, the signal needs to be caught by something, a cell tower. Tower receivers are built to pick up those faint waves. Your phone sends to the nearest tower with the strongest signal. That tower decodes the radio wave back into a digital signal. Then it routes that data through the network to the recipient. This happens in both directions, sending and receiving at the same time. While you're talking, the other person is also talking. Both voices are rapidly converted to data streams. It's a constant dance of send and receive, all happening in fractions of a second. You've probably heard the term cellular or cell phone. But what does the cell part mean? It's not the phone, it's the network it connects to. Operators divide the area into small geographic cells. Each cell typically has a tower or set of antennas at its center. Cells are often arranged in a hexagonal or honeycomb pattern for efficient coverage. This lets networks reuse the same frequencies in non-adjacent cells. Frequencies used in cell A can be reused in cell G far enough away. Distance prevents interference. That's how networks support millions at once. What happens when you're moving and on a call? Signal to the first tower weakens while the next tower's signal strengthens. The network constantly monitors these signals. Before you lose connection, the network performs a handoff. It gives your phone a new channel in the new cell. It happens so fast you don't notice. The handoff is the secret sauce of mobile communication. Without it, calls would drop at cell boundaries. A central hub, the Mobile Switching Center or MSC, coordinates this. Think of the MSC as an air traffic controller for your call. It tracks which cell you're in and manages handoffs, and connects your call to the wider phone and internet networks. Whether to another mobile or a landline, the network routes your call. This invisible web of cells and switches lets you communicate from almost anywhere, and it's constantly evolving to keep up with demand. If you were to crack open your smartphone, which please don't actually do, you'd find a marvel of miniature engineering. Let's start with the most obvious, the screen. The display is your primary window into the digital world. It's also a sophisticated input device. a capacitive touchscreen that senses your touch. Powering it all is the battery, often a lithium-ion cell. Without it, your pocket computer is just an expensive paperweight. Li-ion is chosen for high energy density and compact size. At the heart is the motherboard, the phone's nervous system. The CPU, often part of a system on a chip, is the brain. It contains billions of transistors and runs trillions of instructions per second. RAM is the short-term memory for active apps. Storage like NAND flash is long-term memory for your apps and photos. Apps, photos, and files live there. A small chip, the SIM, is essential for connecting to the network. It stores a unique ID that tells the carrier who you are. Inserting a SIM logs you into the cellular network. Newer phones increasingly use embedded SIMs, eSIMs, that can be programmed digitally. They're provisioned over the air rather than via a physical card. Those tiny parts work together to make your phone operate. From screen to SIM, each component has a critical job. And when they all cooperate, the result is a powerful, pocket-sized machine. While the hardware is the body of the phone, the software is its soul. It's what brings the device to life. The operating system, iOS or Android, is the master controller. You're probably familiar with the two main players, iOS and Android. Manufacturers build on top of these OS platforms. The OS manages the phone's hardware resources, the CPU, memory, battery, and screen. It also provides the home screen, settings, and notification system. The OS decides which tasks use the CPU and when. When you open an app, the OS allocates memory and resources. When it closes, memory is freed. Apps run in sandboxed spaces for security and stability. Apps let you do everything from texting to editing 4K videos on the go. The OS ensures resources are fairly allocated to keep everything smooth. Modern SoCs include neural engines that run on-device AI tasks. GPUs render console-quality graphics on phones, and the OS manages multiple tasks without breaking a sweat. Hardware and software together define the modern smartphone. Software harnesses hardware to make the experience intuitive and personal. It's a beautiful synergy of silicon and code. And with every generation, both hardware and software get faster, smarter, and more capable. The journey of the mobile phone, from a bulky novelty to the sleek device in your pocket. The first public handheld call was made in 1973 by Martin Cooper. The Motorola Dynatac was huge, over 2 pounds and nicknamed the Brick. It offered about 30 minutes of talk after a long charge. Through the 80s and 90s, phones shrank to fit pockets. Bag phones and early flip phones made mobility more practical. The 2G era brought digital calls and SMS texting. 3G introduced practical mobile internet, email, simple streaming, and browsing. This was the first step into true smartphone experiences. Then came 4G LTE, a game-changer for mobile data speeds. HD streaming and smooth video calls became the norm. App stores exploded, giving birth to the app economy. Phones evolved from simple communicators to pocket computers. 2007 changed everything with the first iPhone. It ditched physical keyboards for a large multi-touch display and intuitive OS. It combined phone, iPod, and an internet communicator. App stores made it easy to distribute software to millions. Both big companies and indie developers could build for phones. Smartphones became central to daily life. From bricks to pocket studios, it's been a remarkable evolution. The App Store unlocked your phone's potential. Launched in 2008, it created a centralized place to discover apps, followed by Google Play and other stores. Any developer could publish to millions. Apps could explode overnight, sparking industries. Suddenly, your phone could do what manufacturers never imagined. A phone could become a musical instrument, a personal language tutor, a personal trainer. This turned phones into open, dynamic platforms. It created entire industries: ride-sharing, streaming, social platforms, and more. From social to shopping to banking, apps reshaped daily life. Navigation apps use GPS to pinpoint your location. Photography apps use advanced sensors and processing to create stunning shots. Fitness apps use accelerometers to count steps. Gaming apps leverage GPUs to render 3D graphics. Apps connect user intent with hardware capability, turning sensors and chips into context-aware tools. The phrase, "there's an app for that," captured the moment. Apps didn't just add features, They launched economies and new ways of working. The true power is the phone's hardware combined with creative software. From navigation to filmmaking to banking, apps turned phones into versatile, personal tools. When we talk about mobile internet, you often hear 3G, 4G, 5G. Those Gs stand for generations, each a major leap in capability. Each leap increases speed, capacity, and capability. 2G brought digital voice and texting, but slow data. Data felt like dial-up, fine for text, not much else. 3G made email, streaming, and true mobile web practical. 4G LTE, rolled out around 2010, was transformative. It brought broadband speeds that enabled HD streaming and fast downloads. This helped launch the app economy and turned phones into entertainment centers. Now we're in the era of 5G, more than just faster downloads. 5G promises incredibly low latency, near real-time responsiveness, and massive device connectivity in small areas. That's critical for real-time systems like self-driving cars. Remote robotic surgery needs ultra-low latency, and immersive AR/VR experiences become practical. 5G is built to connect not just people, but everything, IoT at scale. From home appliances to industrial sensors, more devices can be online simultaneously. If 4G connected people, 5G aims to connect everything. It's a more robust, responsive network for tomorrow's demands. As 5G rolls out, it will unlock services we're only beginning to imagine. Another generational leap redefining what's possible with wireless. It's hard to overstate the importance of the mobile phone today. In a few decades, it became central to modern life. It's the first thing many of us check in the morning and the last at night. Your phone is your wallet, your map, your bank. For many, a phone is their first and only computer and gateway to the internet. It provides access to education, financial services, and economic opportunity. The phone is a powerful tool for democratization and empowerment, but it comes with challenges: privacy, security, and digital well-being. The same tool that connects us can also isolate us if not used mindfully. Managing our relationship with phones is key. Use focus modes and limits. Be intentional so phones serve you, not the other way around. Phones reflect who we are and where we're headed, from invisible radio waves to complex software, to the apps that power our days. Knowing how it works deepens appreciation. It makes the seamless, powerful, and personal experience even more impressive. The mobile phone is the centerpiece of our digital lives, and it's not going anywhere.